RMgx, RMgx में मैग्नीशियम जो है वो एक मेटल है, तो क्योंकि ये अल्कलाइन अर्थ मेटल है तो इस पे चार्ज +2 होगा। अब इसको न्यूट्रल करने के लिए तो इसके पास वाले जो ग्रुप हैं दे विल बी हैविंग -1 चार्ज, राइट। तो ये जो X है एक्चुअली मोस्टली केसेस में ये क्या होता है, हेलोजन्स ही होते हैं। और खैर क्लोरीन हो सकता है, क्लोराइड हो सकता है, ब्रोमाइड हो सकता है और आयोडाइड हो सकता है। दिस इज द हेलोजन। और इसको अगर अपन इसका नेम देखें तो हो जाएगा एल्काइल, एंड देन वी कैन कॉल इट मैग्नीशियम। अल्काइल मैग्नीशियम, क्लोराइड है तो क्लोराइड, ब्रोमाइड है तो ब्रोमाइड, हम सिंपली लिख देते हैं हैलाइड, राइट। ठीक है, तो यहाँ पे कार्बन जो है मतलब इट इज ए सोर्स ऑफ R-, का ये सोर्स है। R- बोले तो जो कार्बन के ऊपर जो माइनस चार्ज होता है दैट इज लाइक कार्बन आयन। और ये मतलब ग्रिग्नार्ड रिएजेंट जब भी हम लोग ले रहे होंगे तो हमें ये R- मिलेगा, राइट, कार्बन आयन। एंड दिस कैन शो टू टाइप ऑफ रिएक्शन। इट कैन बिहेव एज न्यूक्लियोफाइल और इट कैन बिहेव एज बेस। दोनों की तरह से बिहेव कर सकता है, बेस की तरह भी बिहेव कर सकता है और न्यूक्लियोफाइल की तरह भी बिहेव कर सकता है, बिकॉज न्यूक्लियोफाइल्स आर दी वन विच आर इलेक्ट्रॉन रिच। तो ये इलेक्ट्रॉन रिच है, कार्बन पे नेगेटिव है। एंड बेस की बात करें तो बेस आर द वन विच कैन एक्सेप्ट द H+। तो क्योंकि ये अनायन है इट कैन एक्सेप्ट द H+, तो इसलिए बेस की तरह भी बिहेव कर सकता है, राइट। ठीक है, तो अगर अपन बात करें R- जो है बेसिकली, जैसे फॉर एग्जांपल मान लो मैंने CH3- लिया, तो CH3- पे कार्बन पे माइनस है, तो कार्बन पे माइनस है तो ये वेरी लेस स्टेबल अनायन है, हाईली रिएक्टिव है। हाईली रिएक्टिव क्यों होगा बेटा, क्योंकि नेगेटिव चार्ज जो है वो स्टेबल नहीं है। नेगेटिव चार्ज स्टेबल होता है व्हेन इट इज ऑन मोर इलेक्ट्रोनेगेटिव एटम, या फिर जब अनायन का साइज बड़ा होता है, फॉर एग्जांपल क्लोराइड, ब्रोमाइड, आयोडाइड, उस केस में अनायन स्टेबल हो सकता है। बट ना तो ये बिगर साइज एटम है, इट बिलोंग टू सेकंड पीरियड, ना ही ये मोर इलेक्ट्रोनेगेटिव है। तो ये जो कार्बो अनायन है एक्चुअली इट इज वेरी रिएक्टिव न्यूक्लियोफाइल। अब ठीक है, तो बेस या न्यूक्लियोफाइल किसकी तरह बिहेव करेगा, डिपेंड्स, किस चीज पे डिपेंड करेगा, ही डिपेंड्स ऑन द रिएक्टेंट। मतलब जो हम रिएक्टेंट ले रहे हैं डिपेंड्स ऑन रिएक्टेंट, रिएक्टेंट पे डिपेंड करेगा। मान लो रिएक्टेंट के अंदर बेटा एसिडिक हाइड्रोजन है, अगर एसिडिक हाइड्रोजन है तो उस केस के अंदर जो ग्रिग्नार्ड रिएजेंट है दैट विल बिहेव एज ए बेस, क्योंकि एसिडिक H है वहां पे, एसिड बेस रिएक्शंस आर फास्टर। लेकिन अगर मान लो एसिडिक हाइड्रोजन नहीं है तो उस केस में ग्रिग्नार्ड रिएजेंट विल बिहेव एज न्यूक्लियोफाइल, ठीक है। हालांकि न्यूक्लियोफाइल की तरह बिहेव करने के लिए भी इलेक्ट्रोफिलिक सेंटर का होना जरूरी है, मतलब पार्शियल पॉजिटिव चार्ज वाली एक साइट वहां पे होनी चाहिए। एग्जाम्पल से समझ में आएगा। सबसे पहले देखते हैं प्रिपरेशन ऑफ ग्रिग्नार्ड रिएजेंट। प्रिपरेशन ऑफ ग्रिग्नार्ड रिएजेंट। प्रिपरेशन ऑफ ग्रिग्नार्ड रिएजेंट, देखो ग्रिग्नार्ड रिएजेंट को कैसे प्रिपेयर करते हैं। सपोज आपके पास में CH3Br है, अब कार्बन पे क्या चार्ज है, पार्शियल प्लस, Br पे क्या चार्ज है, पार्शियल माइनस। आपने सीधा यहाँ पे ले लिया मैग्नीशियम मेटल, तो यहीं से डायरेक्ट बन जाएगा आपका CH3, एंड देन ये हो जाएगा Mg, एंड देन ये हो जाएगा आपका Br, CH3 MgBr, एंड वी कैन से इट इज ए सोर्स ऑफ CH3-, राइट। तो ये कैसे हुआ, देखो मैग्नीशियम मेटल है, मैग्नीशियम का काम क्या है बेटा, मैग्नीशियम का काम है इलेक्ट्रॉन डोनेट करना। एंड हाउ मेनी इलेक्ट्रॉन इट कैन डोनेट, 2 इलेक्ट्रॉन्स। तो देखो ये आपको RX का बॉन्ड दिख रहा है, ये वाला बॉन्ड होगा ब्रेक, और यहाँ पे 2 इलेक्ट्रॉन्स है, तो विच वन विल एक्सेप्ट 2 इलेक्ट्रॉन्स, कार्बन, क्योंकि इस पे क्या चार्ज है, पॉजिटिव। तो ये तो Br- की फॉर्म में निकल गया, एंड ये जो कार्बन पे प्लस आया इस बॉन्ड के टूटने के बाद में, इसने 2 इलेक्ट्रॉन एक्सेप्ट कर लिए। तो कार्बन पे प्लस है ऑलरेडी, एंड इट इज एक्सेप्टिंग 2 इलेक्ट्रॉन, तो पहले ये न्यूट्रल बनेगा by taking 1 electron, and by taking 1 more electron it will become carbon ion, राइट। इसलिए हमें यहाँ से मिलता है कार्बन पे माइनस, Mg पे +2 और Br पे -1, राइट। तो ये कहीं भी बना सकते हैं अपन, मान लो ये बेंजीन है और बेंजीन के ऊपर लगा हुआ है Br, ठीक है। तो आपने ले लिया मैग्नीशियम, तो ये बन जाएगा PHMgBr। मतलब जो ये आपको बेंजीन दिख रहा है एक्चुअली इट विल बी हैविंग ए माइनस चार्ज नाउ इन द फॉर्म ऑफ ग्रिग्नार्ड रिएजेंट, राइट। और देखो मान लो मैंने ये लिया Br, तो यहाँ पर भी अगर आपने मैग्नीशियम लिया then again you will be getting MgBr +2 -1 and -1, तो ये अनायन हो जाएगा। हालांकि मतलब सीधी सी बात यही है कि ग्रिग्नार्ड रिएजेंट के साथ में जहां पर में मैग्नीशियम लग जाएगा तो जो कार्बन वाला पार्ट होगा दैट विल बी कार्बो अनायन, राइट। तो अब हम बात करेंगे, ये हमने देख लिया प्रिपरेशन कैसे करते हैं एंड हमने देखा हाउ इट कैन बिहेव। अब अपन देखेंगे इंडिविजुअली जब ये बेस की तरह कैसे बिहेव करता है और न्यूक्लियोफाइल की तरह कैसे बिहेव करता है। तो नाउ फर्स्ट वी विल सी Grignard reagent as a base. Grignard reagent as a base. Grignard reagent as a base देखते हैं अपन। Okay. Now see. Suppose we are having here CH3 C double bond OH। तो ये जो हाइड्रोजन है दिस इज एक्चुअली एसिडिक हाइड्रोजन क्योंकि कार्बोक्सिलिक एसिड का हाइड्रोजन है। और फिर आपके पास में है CH3 MgBr। CH3 MgBr जो है वो एक बेस है, राइट, वो एक बेस है। यहाँ पे कार्बन पे क्या चार्ज है? माइनस चार्ज है। देन व्हाट विल हैपन, तो ये जो कार्बो अनायन है ये इस H+ को ले लेगा, तो यहाँ पे अनायन आएगा। अनायन के पास में ये जो दूसरा वाला पार्ट है ये अटैच हो जाएगा। सो वी विल बी गेटिंग CH3 C डबल बॉन्ड O MgBr, और साथ में क्या होगा CH3 माइनस ने एक H+ एक्सेप्ट कर लिया तो ये मीथेन बन गया, राइट, मीथेन बन जाएगा ऐसे। ठीक है, अब बेटा ये जो है एक्चुअली अगर आप ध्यान से देखो तो इट इज O-। अगर इसको हमें वाटर देना हो तो आप यू कैन टेक H+, तो यहां से क्या बनेगा CH3 C डबल बॉन्ड OH बन जाएगा, राइट। और MgBr और Mg के साथ भी क्या लग जाएगा OH। क्यों? क्योंकि अगर आप ध्यान से देखोगे तो मैग्नीशियम के साथ में मतलब वाटर अगर आप यहाँ पे रिएक्ट करा रहे हैं तो वाटर में देर इज H+ एंड OH-, तो H+ तो यहाँ चला गया, बट मैग्नीशियम के एक चार्ज को कौन बैलेंस करेगा? मैग्नीशियम इज हैविंग 2+, सो 1 इज बैलेंस्ड बाय Br, अनदर -1 इज बैलेंस्ड बाय OH- ऑफ द वाटर, तो ये बन जाएगा, राइट। साइड प्रोडक्ट जो है उतना इंपॉर्टेंट नहीं है, मेन प्रोडक्ट इज दिस वन, राइट। तो देखो और देखो एग्जांपल। अब हमें ये पता होना चाहिए, like we should know which hydrogens are behaving as acidic hydrogen, कौन से हाइड्रोजन जो है वो एसिडिक हाइड्रोजन की तरह बिहेव करते हैं। ओके, लेट अस सी एसिडिक हाइड्रोजन्स। एसिडिक हाइड्रोजन, एसिडिक हाइड्रोजन्स की तरह कौन बिहेव करेंगे? फर्स्ट, हाइड्रोजन attached with more electronegative atom, मोर इलेक्ट्रोनेगेटिव एटम, मोर इलेक्ट्रोनेगेटिव एटम के साथ जुड़े हुए हाइड्रोजन्स जो होंगे एक्चुअली ग्रिग्नार्ड वहां से H+ ले लेगा, राइट। तो मोर इलेक्ट्रोनेगेटिव एटम में जैसे आपके पास में आ गया हेलोजन, आपके पास में आ गया ऑक्सीजन, आपके पास में आ गया नाइट्रोजन, आपके पास में आ गया sp हाइब्रिडाइज्ड कार्बन, राइट। ऐसे केसेस में अगर आपके पास में इन एटम से अगर हाइड्रोजन कनेक्टेड है तो ग्रिग्नार्ड विल कंसिडर्ड देम एज एसिडिक हाइड्रोजन, और उस केस में वो H+ वहां से निकल जाएगा। मतलब उस केस में ग्रिग्नार्ड रिएजेंट विल बी बिहेविंग एज ए बेस रेदर देन न्यूक्लियोफाइल। और देखो हाइड्रोजन अटैच्ड विथ बिगर साइज एलिमेंट, हाइड्रोजन अटैच्ड विथ बिगर साइज एलिमेंट। बिगर साइज एलिमेंट में जैसे क्लोरीन आ गया, ब्रोमीन आ गया, आयोडीन आ गया, सल्फर आ गया। तो मान लो ऐसे एटम पे भी जब H+ है तो वाई दे आर कंसिडर्ड एज एसिडिक हाइड्रोजन, तो मैं रीजन बताता हूँ आपको। एसिडिक हाइड्रोजन कब कहा जाता है? जब H+ निकल जाए और जो अनायन बने, इफ दैट अनायन इज क्वाइट स्टेबल, तो हम कह सकते हैं उस H+ का निकलना आसान है, दैट इज कंसिडर्ड टू बी एसिडिक हाइड्रोजन। तो अनायन इज स्टेबल व्हेन इट इज either on the more electronegative atom or when it is on bigger size of atoms। बड़े साइज वाले एटम्स पे भी अनायन जो है वो क्या होता है? स्टेबल होता है, ठीक है। ओके, उसके बाद में कुछ और केसेस लेते हैं, जैसे फॉर एग्जांपल थर्ड में लेता हूं ये वाला। अब यहां से ये जो हाइड्रोजन दिख रहे हैं अपने को, ये जो मैंने हाइड्रोजन इंडिकेट किए हैं, एक्चुअली दीज हाइड्रोजन्स ये तो कोई मोर इलेक्ट्रोनेगेटिव एटम से नहीं जुड़े हैं, ये तो कार्बन से ही जुड़े हैं, एंड दीज आर नॉट ऑन बिगर साइज एटम, स्टिल दे आर एसिडिक। क्यों? रीजन देखो आप, जैसे ही आप एक H प्लस निकालेंगे तो यहां से बनेगा अनायन, एंड ये जो अनायन है इसकी वजह से कंपाउंड इज एरोमेटिक। कंपाउंड क्या है आपका? एरोमेटिक कंपाउंड बन गया है। ठीक है, एरोमेटिक कंपाउंड बन गया है तो मतलब हाईली स्टेबल है, 6 pi electrons are there, highly stable compound है। तो फाइनली आई सेड हाइड्रोजन H प्लस के निकलने के बाद जो अनायन है, इफ दैट इज स्टेबल दैट मीन्स द हाइड्रोजन वाज एसिडिक। तो अनायन इज स्टेबल बिकॉज वो एरोमेटिक कंपाउंड है, इसलिए वी कैन से ये जो कंपाउंड, ये जो हाइड्रोजन से क्या है, एसिडिक हाइड्रोजन है। उसके बाद एक और इंपॉर्टेंट केस आता है एक्टिव मेथिलीन का, एक्टिव मिथाइलिन। एक्टिव मिथिलीन किसको बोलते हैं? देखो CH2 आपने देखा, और इसके साथ में अगर दो इलेक्ट्रॉन विड्रॉइंग ग्रुप लगे हो तो दिस इज नोन एज एक्टिव मिथिलीन। मिथिलीन कहा जाता है CH2 ग्रुप को जब उसकी दो वैलेंसी फ्री होती है, और उसके साथ में अगर आप इलेक्ट्रॉन विड्रॉइंग ग्रुप लगा दोगे, स्ट्रॉन्ग इलेक्ट्रॉन विड्रॉइंग ग्रुप, देन दैट बिकम्स ए एक्टिव मिथिलीन। व्हाई? देखो एग्जांपल लेते हैं, लेट अस टेक एन एग्जांपल, CH2 C डबल बॉन्ड O, CH2 C डबल बॉन्ड O। देखो अगर मैं यहां से H प्लस रिमूव करता हूं तो यहां से जब आप H प्लस निकालेंगे, यू विल बी हैविंग anion here, and this anion can show resonance on both the sides। दोनों ही साइड वो रेजोनेंस शो कर सकता है। दोनों साइड जब रेजोनेंस करेगा बेटा, दैट मींस द अनायन इज स्टेबल, एंड अनायन इज स्टेबल दैट मींस द हाइड्रोजन वर एसिडिक। इसीलिए क्योंकि ये जो CH2 है, ये जो मिथाइलिन है, द हाइड्रोजन ऑफ दिस कार्बन आर एसिडिक इनफ, इसलिए वी आर कॉलिंग इट एक्टिव मिथाइलिन। दीज हाइड्रोजन्स आर एसिडिक, एक्टिवली इट विल पार्टिसिपेट इन द रिएक्शंस, राइट? इसलिए अपन बोलते हैं इसको एक्टिव मिथाइलिन, राइट? तो यहाँ पर होने क्या चाहिए? इलेक्ट्रॉन विड्रॉइंग ग्रुप। इलेक्ट्रॉन विड्रॉइंग ग्रुप के एग्जांपल्स जैसे इट कैन बी NO2, इट कैन बी साइनाइड, इट कैन बी C डबल बॉन्ड O वाले ग्रुप्स, राइट? दीज आर स्ट्रॉन्ग विड्रॉइंग ग्रुप्स। ओके, तो ऐसे केसेस में जो हाइड्रोजन्स दिखेंगे हमें, देवर कंसिडर्ड एज एसिडिक हाइड्रोजन। तो अब अपन एक क्वेश्चन करते हैं, प्रिडिक्ट द प्रोडक्ट। फर्स्ट एक एग्जांपल मैं आपको बताऊंगा, देन यू हैव टू ट्राई। CH3 MgBr plus H2O, C2H5 MgBr plus ROH, pH MgBr plus this one D, pH C triple bond CH plus pH MgBr, then E, pH MgBr plus CH3 C triple bond C, CH3 F, pH MgBr plus G, pH MgBr plus NET3H, C2H5 MgBr plus anisole I, CH3 MgBr plus phenol. After I, let us take one more, that is G, CH3 MgBr plus cinnamic acid। ओके, देखो एक मैं बताता हूँ इनमें से, दिस इज द क्वेश्चन एंड नाउ you have to solve it. One I can explain. Suppose we are taking this one. तो इस रिएक्शन के अंदर what you have to take, you have found that this is a Grignard reagent, okay, and this hydrogen is there which is acidic hydrogen. So here this pH minus will be behaving as a base because acidic hydrogen is present in the molecule. So this will take this acidic hydrogen. So what we'll be getting? pH minus. If that accept a proton, then you will be getting a benzene. That's it. Plus side product will be pH C triple bond C minus, and then there will be MgBr. This is what the products will be there in the reaction, right? Now you have to do for all the reactions. Okay, done, Hart?
Yes, kind of. We can discuss.
Chaliye, let us see the products. In the first one, we can see the hydrogen is attached with oxygen. So hydrogen more electronegative atom से connected है. So it will take the H plus. Grignard will behave as a base because hydrogen is there which is connected with more electronegative atom. तो यहाँ से बनेगा CH4 plus. Like now it will be OH minus because H plus is released from here. So we will be getting MgOH-Br. उसके बाद नेक्स्ट केस की बात करें तो C2H5 minus BH plus ले लेगा यहाँ से. तो we will be getting C2H6 plus MgOR is there and then Br is there, right? pH MgBr की बात करें तो pH MgBr में जो हाइड्रोजन्स दिख रहे हैं अपने को, actually these hydrogen will be taken by the pH minus, so we will be getting this as the product. यहाँ माइनस आ जाएगा, here MgBr will be there plus pH minus has accepted the H plus, तो ये बन जाएगा आपका बेंजीन. उसके बाद ये तो हो गया. इसकी बात करते हैं. इस केस में pH minus is there, but यहाँ पर you can see there is no acidic hydrogen. तो यहाँ पे कोई भी एसिडिक हाइड्रोजन नहीं है, नो एसिडिक H. तो एसिडिक हाइड्रोजन नहीं है, इसलिए दिस न्यूक्लियोफाइल, दिस बेस कैन नॉट अटैक हियर. एंड द सेकंड थिंग, सर आप ये बताइए सर, ग्रिग्नार्ड कैन बिहेव एज अ बेस न्यूक्लियोफाइल आल्सो. So can it not behave as a nucleophile here? No, because this itself is a nucleophile. If you remember, alkene and alkyne, they are also nucleophile, and this pH minus is also a negative charge. So reaction will not happen between them, right? No reactions.
Yes.
उसके बाद बात करते हैं F वाले केस की. तो इसमें भी ये हाइड्रोजन दिख रहा है. This is acidic because one thing, it is connected with nitrogen. Second thing, when you remove this, the anion will be doing a good conjugation. तो इसलिए that is a acidic hydrogen. So what will be the product here? Product will be like benzene बन जाएगा, and then here we will be having MgBr.
Okay.
pH MgBr and NET3. Will there be any reaction? You tell me. I don't think so, because this itself is a nucleophile. Nitrogen is having a lone pair, and there are no acidic hydrogens. Hydrogens are just attached with carbon only. So no reaction at all. No reaction. If we talk about H, so C2H5 anisole. What is anisole? Benzene is having OCH3 group, that is anisole. Benzene is having OCH3 group, that is anisole. Now what will happen? You can see again there is no acidic hydrogen, right? Again you can see the oxygen itself as a nucleophile. So no reaction will happen between them. No reaction. Phenol, we know phenol is, this is phenol, benzene having OH group. तो अब क्या होगा? अब ये जो CH3 माइनस है यहाँ से H प्लस ले लेगा, तो हमें क्या मिलेगा? हमें मिलेगा CH4 प्लस क्या मिलेगा हमें? बेंजीन, बेंजीन के ऊपर O माइनस, एंड O माइनस विल बी हैविंग MgBr. ठीक है. सिनेमिक एसिड, व्हाट इज सिनेमिक एसिड? सिनेमिक एसिड के अंदर हमें देखने को मिलता है pH, CH double bond C, and then COOH. That is cinnamic acid. Some common names are actually very important, right? तो सिनेमिक एसिड में there is a carboxylic acid unit. तो एसिडिक हाइड्रोजन है, एसिड बेस रिएक्शन होगी तो CH4 मिलेगा, एंड देन साथ में pH, C double bond C, COO minus, and then MgBr. This is what we will be getting as the product. So have you understood this reaction?
Yes.
Okay. Now Now we will see role of Grignard as nucleophile. Second, we can say Grignard reagent as nucleophile. Grignard reagent as nucleophile. Fine. So अगर हम बात करें न्यूक्लियोफाइल की, तो क्योंकि R माइनस है एंड R मीन्स कार्बन इज हैविंग द नेगेटिव चार्ज, तो जब कार्बन पे नेगेटिव चार्ज है तो उस केस के अंदर इट इज अ वेरी स्ट्रॉन्ग न्यूक्लियोफाइल बिकॉज दैट नेगेटिव चार्ज इज नॉट स्टेबल एट ऑल, राइट? तो न्यूक्लियोफिलिक एडिशन विल हैपन. Nucleophilic addition takes place. And nucleophilic addition जो होता है बेटा, that will be on polar pi bond, right? On polar pi bond. Whenever we talk about the addition reaction happens on pi bond only, right? When it is a polar pi bond, you will see nucleophilic addition. When it is a non-polar pi bond, like C double bond C, alkene and alkyne, then you will see electrophilic addition, like reaction of alkene with HBr, reaction of alkene with Br to halogen. So these are electrophilic addition. But this time we are seeing as nucleophilic addition because the attacking species is a nucleophile. Okay, let us see it by an example. We are having our C double bond H, और यहाँ पर चलो R की जगह कुछ ले लेते हैं. Let us take here CH3. And now what will happen? यहाँ पर हमने लिया C2H5 MgBr. तो इससे बस हमें समझ जाना है कि that it is C2H5 minus. यहाँ पर कार्बन is having a positive charge because oxygen is more electronegative. तो ये electrophilic site हो गई है, ये nucleophilic site हो गई है, right? So reaction will happen between them. This nucleophile is going to attack here, right? And you can see carbon is going to make the fifth bond, which is not possible. So now the previous one bond will got broken. ये टूट जाएगा ऐसे, तो हमें क्या मिलेगा देखो, we will get CH3C O minus हाइड्रोजन, और यहाँ आ जाएगा C2H5, ये आ जाएगा. एंड ऑफ कोर्स यहाँ पर क्या लगा होगा, यहाँ पर लगा होगा MgBr. Then if we supply in the next step, if we give this anion as H plus, so what will happen? This H plus is used actually after Grignard so that this O minus get protonated and you get alcohol as the final product. So CH3, COH, C2H5 and hydrogen, ये मिलेगा. And you can see this is a which degree alcohol? This is a 2 degree alcohol. 2 degree alcohol मिल जाएगा यहाँ से अपने को. राइट, नेक्स्ट देखते हैं अपन.
Yes.
नेक्स्ट अगर अपन देखें, यू हैव टू मेक द प्रोडक्ट HC double bond OH and then CH3 MgBr and then suppose let us take that was CH3C double bond OH, और यहाँ लेते हैं CH3C double bond O and this is suppose again CH3 and then CH3 MgBr. In first step Grignard is taken, in second step H3O plus is taken, in second step H3O plus is taken. So you have to write product direct. For these reaction, what will be the product?
Yes. We will attach.
So in the first case, CH3 minus is there. तो CH3 minus यहाँ अटैक करेगा और ये बन जाएगा CO minus. So जो प्रोडक्ट मिलेगा हमें वो मिलेगा HCO minus H and CH3. एंड सेकेंड स्टेप में हमने H प्लस ले रखा है, तो H प्लस की वजह से क्या होगा, दिस O माइनस विल कन्वर्ट इनटू OH. right? And you can see it is a primary alcohol, 1 degree alcohol it is, right? इसकी बात करें तो इसमें भी क्या होगा, इसमें भी CH3 माइनस क्या करेगा, अटैक करेगा यहाँ पर, and we will be getting the product as COH, CH3, CH3, and this is again CH3, and this is what, this is 3 degree alcohol, ये 3 degree alcohol है. तो you made the same products. Did you make the same products?
So, your voice wasn't clear. What's up?
I was saying, have you made the same products?
Yes, sir.
Okay, fine. So in this
But
case, we are
position placement was different. Like my CH3 was on top.
Okay,
And
no,
OH was
that is
on.
not the issue. That is not the problem, because this carbon is actually tetrahedral. You can place the group anywhere,
Yes.
right? All the positions are equivalent, so no problem. So with aldehyde and ketone, the reaction happen in this way. Finally, you will be getting the alcohol as the product. And suppose this carbon, which was already having a carbon, now you are attacking, so you will be getting a 2 degree alcohol. The carbon which was not having any carbon, if you attack the Grignard, you will be getting 1 degree alcohol. The carbon which was having 2 carbon attached, now the next carbon is again attacking, so you'll be getting 3 degree alcohol, right? So these are the products we will be getting, right? Now,
Yes.
now let us see another important reactions. Suppose R C double bond O is there, and now leaving group is present this time. With C double bond O, you are having the leaving group. So what does it mean? Like, sir, which group will be coming under the category of leaving group? First thing, halogens. For example, chlorine is there, bromine is there, then they will be considered as leaving group, like RCOCl. So Cl will be leaving group here. And then OR. OR means, suppose RC double bond OR is there, then that is ester. So OR will also be a leaving group. Then O C double bond O C, like R, we can say it R. So when it is the case, so you will be having R C double bond O C double bond O R. Then it is anhydride. It is anhydride. So in the case of anhydride, this will be a leaving group, right? Another case,
Yes.
we can take the last one is NR2. NR2. So suppose RC double bond O NR2 is there, then this will also be a leaving group. Okay. So what happens this time? Let us do it by an example. Taking an example, हमारे पास में है CH3 C double bond O and Cl है अपने पास में, और यहाँ है हमारे पास में CH3 MgBr. तो CH3 माइनस जो है वो एज ए न्यूक्लियोफाइल यहाँ अटैक करेगा, राइट? यू कैन सी ये एक पॉजिटिव चार्ज है, डेल्टा पॉजिटिव चार्ज है, सो ये बॉन्ड जो है ये ओपन हो जाएगा. तो यहाँ से क्या मिलेगा, यहाँ से मिलेगा CH3 C O पे माइनस, एंड दिस इज CH3 एंड दिस इज Cl, राइट? ऐसे ही होगा बेटा, CH3 माइनस ने अटैक किया, O माइनस बन गया. नाउ दिस O माइनस विल कम बैक बिकॉज यू आर हैविंग द लिविंग ग्रुप, राइट? तो जब जब लिविंग ग्रुप होगा तो अगेन द रिएक्शन विल कम बैक. तो यहां से बनेगा CH3 C डबल बॉन्ड O एंड CH3, और वहां से Cl रिमूव हो गया, राइट? एंड यू कैन सी, अगर मान लो ग्रिग्नार्ड का एक इक्विवेलेंट और है हमारे पास, वी हैव रिएक्टेड ग्रिग्नार्ड वंस, नाउ वी कैन अगेन शो द रिएक्शन विद ग्रिग्नार्ड बिकॉज इट इज अगेन ए कीटोन, राइट? कीटोन पे फिर से रिएक्शन हो सकती है, बट दिस टाइम दिस कीटोन इज हैविंग नो लिविंग ग्रुप, राइट? तो फाइनली जो प्रोडक्ट मिलेगा वो मिलेगा CH3 CO माइनस CH3 CH3. एंड नाउ व्हाट वी कैन डू, हम फाइनली थोड़ा सा H प्लस ले लेते हैं, और H प्लस की हेल्प से वी विल बी गेटिंग द प्रोडक्ट एज दिस. ये प्रोडक्ट मिलेगा हमें, राइट? तो इसमें एक चीज नोटिस करो आप, यू कैन सी वन थिंग विच इज वेरी इंपॉर्टेंट, दैट ये जो ग्रिग्नार्ड है यहाँ अटैक कर रहा है, एंड यू आर हैविंग ए लिविंग ग्रुप. So जब C double bond के पास में living group है, 2 moles of Grignard will be used, right? And you can see जब C double bond के पास में कोई living group नहीं था, then you have used only 1 mole of Grignard. Suppose here is also Cl. So now how many mole of Grignard will be used, beta? 1 mole will be used, this Cl will remove. Another mole will be used, this Cl will remove. Now again the CH3 minus can react. So the thing is RC double bond O living group is there. So 2 mole of Grignard is used. 2 mole of RMGX can be used for complete reaction, right? Suppose both side living group are there. Living group, C double bond O, living group. Then in this case, 3 mole will be used, right? So we can see number of living group plus 1. Number of living group plus 1 is the mole of Grignard. What we can use, right? Can be used. Okay, fine. So have you understood this thing?
Yes.
So will you be making the product for another reaction? You have to solve for this one. C2H5, C2H5, C double bond O, OCS3 is there. Okay, and the reaction is with pH, Mg, Br, and that is in excess first. So you will be making A, then finally S3O plus you have to take, and finally you'll be making B. So आपको आराम से बनाओ product. You have to finally make A and B. You can ask any doubt, like solve करते time कोई doubt.
Okay.
So we can see pH minus first step will be attacking here, and we can directly remove this. Like I know what will happen. O minus will come back, then this will get removed. But we can directly also write. So we will be getting C2H5, C double bond O and pH, right? This will be formed when we use 1 mole, right? pH MgBr. Then you can see again the reaction can happen because again it is a ketone. So pH minus will attack here, and we will be getting again C2H5, C, O minus, pH and pH. Yes, and finally now this is your A. Now the reaction cannot happen because there is no new living group now. So now if we just take S3O plus, we will be getting the product as C2H5, carbon, OH, pH and pH. Got it?
Got it.
This is what you got, the same product?
Yes.
Very good. So now these reaction can be happen intramolecularly also, and then these becomes a quite important type of reaction. Suppose intramolecular attack we are doing. Intramolecular nucleophilic attack. So suppose we are having C double bond O, and this is Cl we are having, और हमने लिया PHMgBr. So we can see that there is a ketone which is having partial positive charge. There is no acidic hydrogen. So this pH minus will be attacking here, and we will be getting O minus. So हमें ये मिल जाएगा O minus. And the other molecule is as it is, and here will be pH. Right. Now what can happen? This O minus. Actually, this Cl is a living group beta. This is a living group. So this O minus can attack here and can remove this existing living group, right? So we will be having the ring edge 1, 2, 3, 4, 5 and 6. 6 member की ring मिलेगी अपने को. So ये जो product है, we will be getting this as the product, and on the next carbon, which is next to the oxygen, we are having carbon and pH. So let us just connect carbon and pH here, and now we can see that it has become a chiral center. So we are getting two products. Like this is the reaction of Grignard also we used, and then after using Grignard, this O minus just attacked to remove the living, right? Okay.
Yes.
So one case I'm giving to you. You have to try first, second. Suppose we are having benzene, and then we are having OH, and then we are having C double bond O, OR. Then we have to take CS3, MgBr. 1 mole is there. 1 mole means we are not using Grignard in the excess. We have to use only 1 mole. Okay, try. So if 1 mole is there, okay. Now you can see actually acidic hydrogen is also there, and the nucleophilic addition can also occur. Right? दोनों ही चीजें हो सकती हैं. कार्बन पे डेल्टा पॉजिटिव भी है और एसिडिक हाइड्रोजन भी है. So when both the possibilities are there and you have to choose one, then what you will be doing? You will be doing the acid-base reaction. You will be treating the Grignard as a base first. Okay, because acid-base reactions are easier and faster also. So we have made O minus, and then this is the case. Now you can see, beta, this is the C double bond. Grignard could attack here, like the R minus can attack here, but this is O minus. This is also a nucleophile. So this intramolecular nucleophile is going to attack here and going to remove this living group, right? So what product we will be getting? We are going to get this as the product. Oxygen, C double bond O, this one, and this is methyl and methyl. So have you understood this one?
Okay.
Got it?
Got it.
Yes. So, and one more thing I'm telling you, that suppose we are having aldehyde, then RC double bond OH is there, then RC double bond O CS3 is there, then RC double bond O OR is there. So the attack of Grignard reagent. So can you tell me, like, what will be the order of attack of Grignard reagent? Suppose we are having all the groups, but we are having only 1 mole of Grignard reagent. Then where the attack will be first? At first, where the attack will be taking place? Okay, let me explain you. You can see the carbon is having the partial positive charge in all the cases, but the charge is not same, right? Charges are different because of these side group. ये जो side group है, इनकी वजह से charge पे effect आएगा. Can we say one thing? अगर positive charge ज्यादा होगा, तो nucleophilic attack भी ज्यादा होगा बेटा. Because nucleophile attack कर ही क्यों रहा है? Because of that deficiency of electron, that positive charge. If more is the magnitude of the charge on the carbon, more will be the chances of attack, or more will be the rate of the reaction. So you can see these are the hydrogen, which are not going to increase or decrease. But this time we are having the alkyl group, which has a plus I. तो plus I की वजह से थोड़ा सा हल्का सा positive charge घट जाएगा. Now we are having plus I from both the ends. So थोड़ा सा ज़्यादा decrease होगा positive charge. This time we are having even resonance. So resonance की वजह से तो positive charge काफी ज़्यादा decrease हो जाएगा, right? So we can see one thing, that nucleophilic attack will be take place at formaldehyde first, then aldehyde, then ketone, and then in the last it will be ester, right? So suppose, and one more thing, yes. Suppose we are also having that group, RCOCl. Suppose we are having RCOCl also. So in this case, like this is a living group, but the thing is this group is having very high minus I. माइनस आई ज्यादा होता है हेलोजन्स का. सो ये जो डेल्टा पॉजिटिव है, एक्चुअली दे विल इंक्रीज द पॉजिटिव चार्ज बिकॉज they have the withdrawing effect. So instead of decreasing the positive, they will increase the positive charge. So that is why Grignard reagent, if it sees this one, it will be attacking first here, right? सबसे पहले यहीं अटैक कराएंगे अपन, right? Because this halogen will withdraw the electrons. So now we are having one question. We are having one question, that is benzene, and then C double bond of Cl is there, C double bond of OR is there, and here we are having PHMGBr, 1 mole. So you have to make the product, beta, right? You have to make the product. Do it.
Yes. So this I'm not very sure about my answer.
Okay. First you tell me where the attack will take place.
Also idea on the double. Yes, on the double bond with
yes.
C.
Right. So PS minus is going to attack here, and you will be getting O minus, and that O minus will come back, and you will be removing this. Right. So we will be getting the product as this one. Benzene, C double bond O, PH, and C double bond O, and this OR. That is the product. What is the problem in this? This is the final product only. Got it?
Yeah.
Like here, what was the question? What they wanted to ask, that where the attack will take place. So attack will take place on the center where the partial positive charge is more. Right?
Yeah, right.
Okay, so next question about Grignard reagent is, we are having suppose PHMGBr, and then suppose you are having CH3O CH2Cl. Then what can happen? You can see the Grignard reagent actually can attack as a nucleophile also, right?
Yes.
So it can do nucleophilic substitution also. And you can see here delta positive is there. This is the living group chlorine. So this pH minus will be attacking here and will be removing this halogen. So we will be getting CH3O CH2, and this is pH. This is what we will be getting. Right. This type of reaction, you can have another reaction also. Suppose CH3 MgBr you are having, and then you are having IBr. Then what will happen? This is having partial positive charge, this is having partial negative charge. CH3 minus will be attacking here, and you will be removing this group. So we will be getting CH3 and I. Iodine having partial positive charge because it is less electronegative. And then suppose we are having ketone, and this is a methyl, right? Once first step I'm reacting this with CH3 MgBr, second I'm reacting this with S3O+. So what will happen? This CH3 minus is going to attack here, and this bond is going to open. So we are having O minus, right? And CH3 will be here. That will be on the des. So O minus, and H plus is given, so we can write OH, and then methyl is there on the wedge. But actually, beta, you can see you can have these things on dash also, right? OH on the dash, and methyl on the wedge, and methyl on the wedge, because that is a chiral center. And now these two compounds are diastereomers of each other, right? The forming compounds are diastereomer of each other. So this is what this was nucleophilic addition. This was nucleophilic addition reaction. Then suppose one more question we are having on Grignard. Now we are having CH3 MgBr. CH3 MgBr, and X is written. X is what? X is the mole of the Grignard which is used. So we have to tell the value of X. Like how many mole of Grignard reagent can be used on this compound. So CH3 minus is going here and it is opening the bond, and O minus will form, right? From here, O minus will form. O minus will come back and this bond will again break, right? Because it is a living group. Ester, you know, ester is a living group. So now we are having here methyl and here O minus, right? O minus, there will be MgBr, right? Okay. So in the next step, you can again see it is again a ester. So again the Grignard can attack second time also. Second time also CS3 MgBr is going to attack. CS3 minus is going to attack here. And this bond is directly we can open, right? So we'll be getting OMGBr. We can write here OMGBr. And then along with this, what we have got, C double bond O, CS3 we have got, and then one more CS3. And better you can see again the group is having ketone, right? So again the Grignard reagent can attack. So CS3 minus is going to attack here. And finally we are getting CS3, CO, CS3, CS3. And that O will be having MgBr. Right? And when we do the hydrolysis, like H plus if we provide, then this will be converted into OH, OH, and OH. So how many moles we can see of Grignard are used? So value of X is coming to be 3. And I told previously that when the living group, suppose it is having 2 living group, no? So number of living group plus 1 is the number of moles of Grignard reagent. So 2-side living group is there. So 2 plus 1 means 3 moles will be Grignard reagents used. Right. So on this basis also, I am giving one more question which you have to solve. Grignard reagent can behave as both base as well as nucleophile. But first, suppose it has both the choices and one equivalent you are having. Then Grignard will be behaving first as base because acid-base reactions are faster. So suppose we are having this thing, CHO, OH, Cl, and here we are having C double bond O, OH, and here we are having SH, suppose. And then we are having CS3 MgBr. And there are X mole of this compound. So we have to find the X mole. Like how many mole of Grignard can be used for this given reactant? Okay, let us see. But you do not have to react it. You just have to see, like this is COCl. So in this case, one living group is there. So we can say, sir, 2 mole will be used here. If we talk about CHO, in CHO only 1 mole will be used because that is C double bond OH. There is no living group. So one Grignard can be used. In the case of OH, there is the acidic hydrogen. So Grignard will be used as a base. Here also acidic hydrogen is present, so 1 mole. Here also acidic hydrogen is present, so 1 mole. Here, in this case, this Cl actually cannot be removed at all. Why cannot be removed? Because it is attached directly to benzene. And we have seen that living group, when it is directly connected to benzene, it will not show SN2 reaction. It will not show even substitution reaction, right? It is very difficult to show substitution here. So how many moles of Grignard are coming? 2 plus 1, 3, 3 plus 1, 4, 4 plus 2, 6. 6 is the right answer. So have you understood it now?
Yes.
Okay. So then we can see some compounds. Hydrolysis means we are breaking a bond, generally a hetero bonds, by water, in the presence of water. So suppose we are having RC triple bond N. This is the first compound and we are doing it reacting it with water in the presence of H plus. So acidic hydrolysis. So like you can see, there is a polar pi bond, right? And there are 3 bonds total. So in CN, carbon is less electronegative, nitrogen is more electronegative. That is also sure. So what you can do directly, like how we can make the product directly here. Carbon is having positive charge. There is water. So from water there will be OH minus, right? How many OH minus can come? 3, because there are 3 bonds we are going to break. So carbon will be having 3 OH. So carbon, when it is having 3 OH, no, then 2 OH will water will get removed. So we will be getting RC double bond O and OH. Whenever you see 2 OH on carbon atom, you just remove a water and you just make double bond O. Okay, double bond O is formed. And then nitrogen. This nitrogen will be having 3 hydrogen, and that will be coming from here. Because in the water, OH minus we have used. So H plus will be coming. H plus will be coming on the negative part. So we will be getting NH3 also. Right? So this is how we can write directly product. So this is the complete hydrolysis of cyanide. And then suppose we are having partial hydrolysis. We are reacting this with H3O plus, but this time we are doing partial hydrolysis. Partial means number of moles of water are not sufficient enough to break all the bonds. So this time what we will be doing, we will be breaking only 2 pi bonds from here. So when we break 2 pi bonds, we will be getting beta 2 OH on the carbon, and 2 OH will convert into C double bond O, and this nitrogen that will be having 2 hydrogen. So when we are doing partial hydrolysis, we will be getting amide, and when we are doing complete hydrolysis, we will be getting acid. One more important thing is that, sir, when we have to do which one, like partial we have to do or complete we have to do? In the case of partial, it will be written, right? Partial hydrolysis. If it is not written, you will be doing the complete hydrolysis. So have you understood this one?
Yes.
Yes. Suppose we are having double bond. RCH double bond NH. Suppose we are having RCH double bond NH, and then we are having S3O plus. So what we will be getting? We will be breaking this time 2 bonds, and carbon will be getting 2 OH, nitrogen will be getting 2 hydrogen. So as a product, we will be getting RC double bond O and hydrogen, right? Because 2 OH will be coming on the carbon atom. Okay, fine. Then this is the second compound. This functional group is imine, right? And that was cyanide. This was cyanide. Cyanide imine. Now the third one. Third one we are having R C double bond O R, and then we are having S3O plus. Okay. So what to do? This is a ester, right? This is ester functional group. So in this case, what will happen? This bond is going to break. This bond is going to break. So it will be having OH minus here. Why? Because this is a partial positive charge, and this is partial negative charge. So this will be getting H plus. So when we do the hydrolysis of ester as a product, we will be getting RC double bond OH plus ROH. Acid and alcohol will be getting. Acid and alcohol will be getting. Fine. Fourth one. If we talk about the fourth one, this was ester. In fourth one, suppose let us take RC double bond OC double bond R, and then we are having S3O plus. So how to make the product this time? This time we'll be breaking this bond as well as this bond. Okay. So like you can directly see beta. C double bond will be getting OH. So we will be making RC double bond OH. And how many will be forming? From this side as well as from this side. So you'll be getting 2 mole of acid. And this oxygen, this will be having hydrogen from here, hydrogen from here. So we will be getting water along with this. Have you understood this one now?
Yes.
Then if we talk about the next case, fifth one, RC double bond OCl. RC double bond OCl plus S3O plus we are having. So what we will be doing this time? We are going to break this one. So OH minus here, H plus here. So we will be getting RC double bond OH and HCl will be getting. RC double bond OH and HCl will be getting. Right. So what we are going to do? We are doing breaking of carbon and C double bond O carbon and this particular group. This bond we are going to break. And in the case of aldehyde and ketone, we cannot break this, right? Because you can see, I have told that this is a living group, this is a living group, this is a living group. That is why we are breaking these bonds, okay? But if suppose you are having ketone or aldehyde, we cannot do their hydrolysis, okay? Suppose we are having RC double bond OH or RC double bond R. So their hydrolysis we won't be doing. No product, right? Actually,
Yes.
when you do the H plus, when you give the H plus to aldehyde or ketone, you just get this thing, which H plus. That's it. You cannot get more than that because in the presence of H plus, this oxygen will get protonated. You will be having a positive charge on this carbon. That's it. Right. And then what can happen? Because you have taken H3O plus, so water will be attacking again, right? And water attacks again, so you'll be getting again OH here. And carbon will be having 2 OH. Then it will be converted back to the C double bond only. So we are getting no product. Water is attacking here. So RC, C will be having 2 OH group now. So we can say that you will be having finally aldehyde only. So R C double bond OH. When we react this with water, medium is acidic, we will be having equilibrium. This one, right? We'll be getting again aldehyde and aldehyde to this. And which one is more stable? This one is more stable. So equilibrium will lies to the backward direction because it is more stable. C double bond O is more stable than the 2 independent CO bonds. Right. So this reaction will be more towards backward, less towards forward in this way. Or we can also say K equilibrium will be less than 1. What do you mean by K equilibrium? K equilibrium is ratio of product and reactant. Because reactant is more stable, so it will be less than 1. Right?
Yes.
Okay, fine. So this we have seen now. Now the last reaction we can see, attack of Grignard reagent. Attack of Grignard reagent on which compound we'll be doing? We'll be doing on cyanide. Right? How we can do this? RC triple bond and we are having, and then suppose we are having CS3 MgBr. So what will happen? This CS3 minus is going to attack here and this bond will open. Right? So we'll be getting RC CS3 double bond N, and like N will be having negative charge. So MgBr will get attached here. Then suppose hydrolysis is given. So what you can see better, like N minus will first become NH. RC CS3 double bond NH. And we have seen that this is a imine group, right? We have seen this is imine functional group. Here we have seen imine functional group. So it will be giving aldehyde. How it will be giving aldehyde? Because we can break this bond and then we'll be getting 2 OH on the carbon atom. So this time, because the carbon is having CS3 also, so we will be getting RC double bond of CS3, right? And along with this, we'll be getting ammonia. This as a product we'll be getting. So have you understood this?
Yes, I understand.
Okay, one more reaction is also there. Attack of Grignard reagent on cyclic ether. On cyclic ether we are doing. So like suppose we are having a 3-membered ring. This is a cyclic ether. And now how to solve it? Grignard is a nucleophile only. CS3 MgBr, that is a nucleophile. So it will be doing nucleophilic attack. Because both the carbon are having partial positive charge, so it can attack on any of them because it is symmetrical. Suppose it is not symmetrical. Suppose it looks like this. Then where we have to attack? We have to attack on the less sterically crowded carbon. We will be doing SN2 reaction. So this bond will open. We will be getting CH3 here and O minus here, and this will again be CH3, right? So this is what we will be getting. Suppose we are having 2-methyl here, then of course we are going to attack on less sterically crowded carbon only on this one. So we will be getting CH3 here, O minus, and CH3 and CH3. Right, this is the simple product we'll be getting. So it is easy when we have to actually attack on the less sterically crowded carbon only. When we are doing attack with the Grignard on the cyclic ether, we have to attack on the less sterically crowded carbon atom. Right, so this is all about Grignard reactions. In the Grignard, what we have seen, I'm just revising it again. Grignard reagent formation. Grignard reagent, because it is a source of carbanion, so it can behave both as nucleophile as well as base, right? And it is a strong one because this is unstable. So when it will be behaving nucleophile and base, it will be depending on the reactant, right? Which kind of reactant you are taking. Now we are having preparation of the Grignard reagent. So generally, sometimes they do not give the Grignard reagent. They first form the Grignard reagent. Suppose this is a RX bond, magnesium. This magnesium will insert here in the bond between RX. So you'll be getting this. In this case also, in this case also. Same thing. So Grignard reagent as a base, when you are having the acidic hydrogen, Grignard will be behaving as a base only. Hydrogen attached with more electronegative atom are the acidic hydrogen, and bigger size atom are also, and the hydrogen, after removal of that, you are having aromatic compound, then that is also acidic hydrogen. Active methylene, this CH2, when it is having 2 electron withdrawing group, then it is active methylene. Predict the product. CH3 MgBr. In this case, what we have done, like this hydrogen was attached to oxygen, which was more electronegative atom. So CH3 minus will take the H from here, and it will be getting CH4. So sometimes they can ask, like CH3 MgBr is used in which of the following case methane will be obtained when they are reacted with CH3 MgBr. Right, this type of question can come. In which of the following case methane gas will be produced when they are reacted with Grignard CH3 MgBr? So where we'll be getting the case in which acidic hydrogens are present, right? In that case, we'll be getting CH4. Grignard is a nucleophile. Nucleophilic addition it can show on the polar pi bond. When you are having the leaving group like this, you will be having more than 1 mole of Grignard used, right? So intramolecular also we have seen. Attack of the Grignard reagent. Suppose 4 compound, different reactants are there, which all can show the nucleophilic addition. But where we have to do the nucleophilic addition, the carbon atom which is having more partial positive charge. Here partial positive charge is slightly decreased due to plus I effect. Here it is more decreased due to more plus I. Here it is even more decreased due to resonance. Right? So Grignard will be attacking first on this one, then this one, this one, this one. Suppose we are having RCOCl type of compound. Then this type of compound is actually, because of Cl, it is withdrawing in nature. So this will be attacking more. Right? So these cases we have seen. And then hydrolysis wala part, and then we have seen on the cyanide. On the cyanide, when we attack, no, you have to add the Grignard here, and then you can directly make the C double bond O, because S3O plus will be given. Attack of Grignard on the cyclic ether, you have to attack on the less sterically crowded carbon atom. Right. Now we can solve some questions on the Grignard reagent.